Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering. Today, I am going to discuss the demonstration of hardness of water. How we are going to measure the hardness in water by using complexometric titration. It is a laboratory experiment in engineering chemistry. So, here the estimation of hardness by complexometric titration. So, there are four types of titration. One is acid-base titration, redox titration, precipitation titration, and complexometric titration. Here we are going to see the complexometric titration. So this reaction involves the complex material like disodium salt of EDTA. Here we are going to see in detail the procedure and as well as the principle involved in this reaction and how we are going to find out the hardness in water. So the aim of the experiment is to find out and measure the hardness of water in tap water as well as boiled water. So the apparatus. So the apparatus which we are using are burette, conical flask, measuring cylinders and indicators. We are using apparatus here and the chemicals required. The chemicals required here are EDTA salt for complexometric titration, then followed by ammonium chloride plus ammonia buffer plus EBT indicator. For preparation of EBT indicator, we need ethyl alcohol also, and then magnesium chloride. So these are the chemicals involved in this reaction. So the theory we are going to see in detail the principle or theory involved what's happening in the water molecule to give the color change. So we are going to see in detail in this experiment and how we are going to titrate with different samples and what we have to add in the water to get the result. So the procedure, it's a step-by-step process that we are going to see in detail. Then observation table for noting the readings. Then calculation followed by the result. So the aim is to estimate the total hardness in water, both permanent and temporary hardness in water by using a standard of EDTA, ethylene diamine tetraacetic acid. So here burette, pipette, conical flask, beakers, standard flask, burette stand and funnels we are going to use in this experiment. So these chemicals required in this experiment are magnesium sulfide, buffer, disodium salt of EDTA and erythrome black tea indicator. This is an indicator. This is an titrant. So the solution which we are taking to titrate or which we are taking in the burette is called the titrant. So this EDTA we are going to use in the burette. Then buffer to maintain the pH and magnesium sulfide to standardize the EDTA. Standardized EDTA solution. So the principle involved here is the hard water contains calcium and magnesium salts. So which forms, so the calcium and magnesium salts present in the hard water reacts with the EBT indicator, erythrome black tea indicator, which forms a wine red complex. So the solution we will get is wine red in color. It is more unstable. So the formed complex, so before the titration, the solution will have wine red color. This is due to the reaction of calcium and magnesium salts with EBT indicator. So the calcium plus magnesium plus EBT or calcium or magnesium reacts with EBT forms CaEBT or magnesium EBT. So this is a wine red color complex and this is highly unstable. This is before titration. So now we are going to titrate with EDTA. So what happens after titration with EDTA? This complex reacts with EDTA complex. Then calcium EBT or magnesium EBT reacts with the EDTA. This is a titrant. So it forms a calcium EDTA or magnesium EDTA complex. This is a colorless complex, metal ion complex. It won't have any color. So once this complex formed, the EBT which is left as free. Once here it got displaced, here EDTA will go and bind this calcium and magnesium. So the EBTA will be released. So the blue color solution will be obtained. So the blue color is the endpoint, which is purely due to the presence of the indicator in the solution. So when free ions are not there, what happens? So when we are going to titrate with the EDTA, the free ions are not available. If free ions are not available, because all the ions present in the water got a complex and formed a complex with EBTA. So there is no free ions in the water. So this EDTA, what happens? It grabs or it extracts the metal ions present with the EBTA. So EBT. So what happens? It is an unstable complex. So when it grabs the ions from the EBT, the EDTA complex with metal ions will be formed and EBT will be left as in the water. This is due to this color. This EBTE is the main cause of the blue color in the solution. So the end point is, first is wine red, before titration, after titration, blue. So this is the principle involved in this reaction. So it actually involves in 4 steps. So this whole process carries out in a 4-step process. First thing is magnesium sulfate standardization, standard preparation, which is going to use for EDTA standardization. So first we have to prepare EDTA. We don't know the exact molarity. Some human errors will be there. So we are going to standardize this EDTA solution with magnesium sulfate standard. So this magnesium sulfate standards were prepared, then titrated with EDTA. Here we have to add buffer indicator. Buffer plus indicator. So the EDTA standardization. Here we will get the EDTA molarity. So the exact molarity of EDTA. So once EDTA molarity was finalized and calculated, then it was ready for titration with hard water as well as permanent hardness water. So both titration we are going to see only after the standardization of EDTA with magnesium sulfate solution. So here these steps are going to see in detail. The step 1. First is magnesium sulfate standard preparation. So in this, approximately this molecular weight of magnesium sulfide is 246. So around 250. So here for 1000 ml of magnesium sulfate, 100 ml of 100 ml of distilled water, we are going to add 0.25 gram of magnesium sulfate. Then we have to add buffer to maintain the pH and indicator to know the color change. Then it was titrated again as the EDTA solution. Here, thus prepared magnesium sulfate solution was taken in 20 ml of magnesium sulfate solution was taken in a conical flask, 2 ml buffer and indicator, which gives a wine red color solution. Then it was titrated with EDTA. The wine red color changes to the blue color. This is the end point. Once the blue color came into the conical flask, we have to stop the reaction. We have to stop the burette flow. Note the burette reading and repeat the titration to get concurrent values. Here we have to tabulate the column. First, magnesium sulfate 20 ml was taken in 3 conical flasks. The initial reading, suppose the burette initial reading will be the 0. So if it is 9 ml, the volume of EDTA consumed is 9. Then from 9, again here it will be the final value in the first column will be the initial value in the second column. Again it was 18.5, suppose, then it is 9.5. So from again 18.5 to 29, then it is 10. So the average of all the 3, so around it will be 9 to 10 ml will be the average, will be taken as a volume. Here the calculation is very simple, like M1V1 equal to M2V2 formula we are using. So here M1 is magnesium, here M1 is magnesium sulfate molarity. That is 0.01 M that we prepared in step 1. Then next thing is EDTA molarity, that we are going to find out. This we don't know, and we are going to find out through this standardization procedure. And the V1 is volume of magnesium sulfate, that we are taking 20 ml. So we can take this V1, this is V1. So the V1 is 20 ml. Then V2 is volume of EDTA consumed. While titrating, the volume of EDTA consumed, this column. So this is V2. So the average, suppose if it is 9.5, the average of these three will be taken as a V2. Here the calculation is M1 is 0.01 M into EDTA molarity. Here M2 we are doing. So M1 is 0.01 M into V1 is 20 ml divided by the V2 is volume of EDTA consumed 9.5. So the simple calculation. So this gives the molarity of EDTA. Suppose it is 0.01 M. Consider it as 0.01 M. So now we got EDTA with value of 0.01 M. Now thus the EDTA solution standardized is ready for the determination of hardness, both permanent and hard water hardness in water. So here we are moving on to the present experiment. So now up to now we completed the standardization procedure. Now the real experiment is we have to take 20 ml of tap water, that is hard water, into 250 ml of conical flask. So 2 ml of buffer solution plus 2 to 3 drops of EBT indicator was added to the conical flask. So here what happened? At a certain pH, actually this EBT indicator forms a complex only above 9.5 pH. So here pH plays a vital role. To maintain this pH, we are adding the buffer solution. Buffer solution is, here what we are preparing is ammonium chloride plus ammonia buffer. So it is a combination of both ammonia buffer and ammonium chloride. It is mainly due to maintain the pH above 9.5. So this indicator was used only to maintain the pH above 9.5, and buffer was used, and to know the color change, this indicator was used. So the wine red color is, we know, the calcium and magnesium ions present in the hard water reacts with EBT, gives calcium EBT or magnesium EBT. This is wine red complex. This happens only in the presence of or addition of 2 ml of buffer plus indicator. Here also indicator. So the wine red complex is formed. So then we have to titrate with the standardized EDTA solution, 0.01 M EDTA solution, until the blue color of the solution was formed. So this has to be repeated until to get the different concurrent values. Same thing, tabular column, again the same thing. So if it is 10, then final 20, here 10. If it is 20, here 30, again 10. If it is 30, again 40, here 10. So if it is, sometimes it happens different values will come, plus or minus 2. So the average concentration of all these three values has to be taken as V2. The volume of this is V2 and this is V1, and molarity of here, molarity of hard water we are going to find now, and EDTA molarity we know by standardization with magnesium sulfate, it is 0.01 M, and the volume of hard water which we are taking is 20 ml. We know V1 and the average is 10. So the calculation is simple. We are going to find out the M3, the hard water molarity. So M2 is, here M2 is EDTA molarity 0.01 M. M3 equal to 0.01 M into V2 is 20 ml divided by 10. So this gives the ppm of hard water. So the total hardness presented, this is the M3. So the total hardness is, this is the M3. So the total hardness is again, total hardness we have to convert into the calcium carbonate equivalents per liter. That's why calcium carbonate molecular weight is 100 and 1000 per, this is for 1 liter. So we are converting, so that's why we have to calculate M3 into 100 into 1000 is the, this is what the total hardness we are going to get. That is in ppm. This is the simple calculation for calculating the total hardness in water. Next thing is, fourth step is, here the fourth step is again to find out the hardness in permanent hardness water. Here what we are doing, 100 ml of hot water is taken in a beaker and boiled until it reduces to the half of the amount. If we are taking 100, it should come to the 50. If we are taking 200, it should come to the 100. So the beaker containing water 100 ml should be boiled until the water becomes 50. If it is 200, then we have to wait until it reduces to 100. So after this type of water has to be taken for standard, for titration. So this is called boiled water we are using for titration. So here again the same thing, we have to filter the water in the beaker and 20 ml of, after filtering, then filter from this 20 ml of sample, then buffer plus indicator. So all the three, like buffer, indicator plus 20 ml of sample has to be taken. So the indicators of 2 to 3 drops is more than enough, which gives color instantly, and 1 to 2 drops is really enough to get the color. Then the wine red complex, due to the calcium here, wine red complex due to the calcium and magnesium salts present in the water reacts with the EBT and forms wine red complex. Then when it was titrated with EDTA, it absorbs the ions from the metal complex formed with the indicator. Then it results in the colorless compound, colorless complex plus free indicator. Then the blue color is formed. So the same titration has to be repeated. Why we are boiling? Here, why we are boiling? Because all the bicarbonates of calcium and magnesium decomposes to what happens? This calcium bicarbonates, this CaHCO3 plus or MgHCO3 when heated, so it converts to calcium carbonate plus magnesium carbonates or magnesium hydroxides and releases CO2 plus H2O. So this is what going to happen in the boiling of this water. So this what happened, this calcium magnesium decomposes to calcium carbonate and magnesium hydroxide respectively. When we filtered, all these salts are removed. These are the bicarbonates, all the bicarbonates, and to remove all these bicarbonates and it was decomposed to calcium carbonate and magnesium hydroxide. This we can filter, and then this water is used for titration. So this is a complexometric titration. We are going to do titration with an EDTA complex. This is a disodium salts of ethylene diamine tetraacidic acid complex. This is a titrant. Prepared with a standard prepared in a standard flask. This we are going to use in the burette. So this is the buffer. This is the titrant prepared with with EDTA, disodium salts of EDTA. The concentration we took is 0.01 m. Here this is a buffer. So to maintain the pH, we are using buffer. This is a combination of ammonium chloride and ammonia. And indicator we are using in this titration. Based on the color change, to know the color change, we are using indicator, EBT indicator, Erichrome black tea indicator. Now we took tap water as well as boiled water for titration. We are taking 20 ml. This is the sample 1. We are taking tap water, 20 ml of this tap water, followed by buffer. Again 10 ml of buffer we are taking. So 10 ml of buffer is added to the sample. Then we are using Erythrome black tea indicator. So just 2 drops of Erythrome black tea indicator was added to the sample. So we got it. This is a wine red complex. This is an indicator with buffer and sample solution. This we are going to titrate against the EDTA solution. So this is an indicator metal ion complex. So the metals present in the water sample got mixed with, forms a complex with indicator, EBT indicator. This is an unstable complex. This is wine red unstable metal ion complex. So we are going to titrate. Now this wine red color will turns into blue this way. So this is an endpoint. So we are going to titrate the solution with EDTA. After the titration, how we are going to find out the endpoint? Because the solution color changes to blue. Now we are starting titration. We have to add drop by drop and we have to shake in a circular way. We have to titrate until the color changes to blue. So once the color change is observed, we have to slow down the titration by adding drop by drop. We are going to reach our endpoint soon. Now the wine red color turned blue. Here we can see. So the color of the solution is blue. The initial color is this wine red color and the solution we got after the titration is blue color. So the same way for temporary hardness water we are using boiled water. So the water is boiled for certain extent, then we are using this water, boiled water. Again we are adding 10 ml of buffer. (10 ml of buffer was added to the sample solution. Then again 2 drops of indicator. So the sample was purple wine red color. Because of less salts it was showing little bit blue color. Then again we have to titrate. Now we got our endpoint soon. Now the color of the solution is blue. So the endpoint came. So we are going to take the reading, like if it is 15 to 20 water consumed means we have to take the ml consumed is as 5 ml. So this is the, here before titration, this is an metal indicator complex which is an unstable compound. So water sample will have some salts, it reacts with the EBT indicator and form this unstable complex. When it was titrated with EDTA, it grabs all the metal ions and converted to this colorless EDTA metal ion complex was formed, which is a stable compound and releases the free EBT indicator which gives the blue color. So here the tabular column, so that, and here we are doing titration. So 3 samples has to be taken. Again this is V2, V4, here V4 and this is V2, here V2. So molarity of hot water is 0, we don't know, that we are going to find. Molarity of EDTA molarity is 0.01 m. And here the calculation is very simple. M4 we are going to find out. M2 is EDTA molarity and V2 is the water which we took, titer value for the EDTA. So suppose here it is 25, then 35, 35, 45, 45 to 60. So suppose 10, 10 and 15. So the average 12. So average 12 we have to take as V4. V2, this is 20. So the same thing, here we will got M4 as X, some value. this has to be converted into permanent hardness into 100. X into 100 into 1000 gives the concentration of hard calcium and magnesium present in the form of hardness in water is dash ppm. So this is some y ppm. So this is for permanent hardness and this is for total hardness. So we know total hardness is a combination of both temporary and permanent hardness. So the simple calculation, total hardness that we got, suppose x, and permanent hardness we got is y. So temporary hardness in ppm is total. So x minus y will give the temporary hardness as z. So here simple, total is nothing but the both combination of permanent and temporary hardness. So y plus z. So we know x and y. So x minus y. If we are subtracting total hardness minus permanent hardness will give us the value of temporary hardness. This is the way we are going to do all the three types of hardness like total, permanent and temporary hardness in water using complexometric titration. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.